Look, I need you to brace yourself for a second here because I am looking right at you and I really have to drop a bit of a bombshell. You are not an independent agent.
Oh, wow. Starting off strong.
Yeah, well, I mean, it's true. You are a survival machine, like a giant lumbering robot vehicle that is blindly programmed to preserve these ruthless, immortal molecules that we know as genes.
It really is a profound shift, in how you view your own existence.
Yeah.
Because we all like to think we're in the driver's seat, right?
Yeah.
Making conscious choices based on what we want. But the reality is that our biology operates on this completely different, almost alien level of control.
Right, totally alien. And to get to the bottom of this, we are diving into a stack of excerpts today from Richard Dawkins' classic work, The Selfish Gene. And the text uses this brilliant metaphor, the Necker cube.
Oh, yeah, the line drawing.
Exactly, that two-dimensional line drawing of a cube where if you just stare at it long enough, the front face suddenly becomes the back face, and the whole orientation just flips inside out in your mind. And we are going to do that to your brain today. We are going to stop looking at life from the angle of the individual organism and, start looking at it from the gene's eye view.
Because when you make that mental flip, the mysteries of life just suddenly snap right into focus.
Okay, let's unpack this, because to really understand why we are just disposable vehicles for these genes, we have to travel all the way back to the primordial soup, right? Billions of years ago. We have to look at how these molecules got put in charge in the first place.
Yeah, so the text describes that early soup as just a chaotic broth of really simple chemicals. You've got water, carbon dioxide, methane, ammonia. But at some point, this extraordinary accident occurred, the birth of the replicator.
The replicator sounds like a sci-fi movie.
It does. But it was just a molecule that happened to have the chemical property of making copies of itself. Which, I mean, it sounds like magic, but the mechanics are just basic chemistry. Building blocks floating in the soup naturally stuck to the replicator in a matching pattern, kind of like a mold, and eventually peeled off to form a perfect copy.
Crucially, though, that copying process wasn't completely perfect.
No, not at all. Think of it like a group of monks painstakingly copying a massive manuscript by hand. Inevitably, someone makes a typo.
Right, they spill some ink, miss a word.
Exactly. Then the next monk copies that typo and adds a few of their own. Through these continuous copying errors, different varieties of replicators emerged. And the soup started to favor molecules that had three really specific traits.
Longevity, meaning they didn't break apart easily. Fecundity, meaning they copied themselves rapidly. And copying fidelity, meaning they were accurate enough to pass those good traits on.
Right. And as those building blocks became scarce in the soup, it became this microscopic arms race. These replicators essentially started waging chemical warfare,
Yes.
literally breaking down rival molecules to steal their building blocks.
Wow, so just ruthless from day one.
Completely ruthless. The ones that survived were the ones that happened to build protective protein coats around themselves to defend against those attacks. And over billions of years, those tiny protein coats evolved into ever more complex bodies.
And ultimately, that mechanical arms race leads to us. We are the complex bodies.
We are. And that history highlights the most humbling realization of this whole perspective. The genes are practically immortal. They leap from body to body down through the generations, surfing through time. Our bodies, on the other hand, are entirely disposable.
Which is just wild to think about. Like, we are designed to eventually die once we've served our purpose of passing them on.
Yeah, and the text brings up Peter Medawar's theory of aging here, which is fascinating.
Right, because if our bodies are just vehicles, you'd think natural selection would design them to last forever to keep making babies. So why do we decay? Why do we get old?
Because natural selection is blind to whatever happens to a survival machine after it is successfully passed on its genes. If a genetic mutation causes a fatal disease in childhood, it obviously never gets passed on. But if the mutation causes a fatal disease at age 70,
It's already been copied.
exactly, it has already been copied into the next generation. So senility and death from old age are really just the accumulation of those late-acting lethal genes. They slip through the net of natural selection because they only kill us after we've already reproduced.
So we age because our genes simply stop caring about our individual survival.
Once their future is secured, yeah, you're on your own.
Man, that's dark. But I am struggling with the timeline here, though. Like, I get that genes take months or years to build a body, patiently pulling protein strings in the womb and setting up our nervous system, but they are slow-moving chemicals.
Extremely slow.
Right. So when I dodge a moving car or, catch a falling glass off a table, my brain is acting in milliseconds. How can my DNA possibly be in control of my real-time, lightning-fast behaviors?
That time lag is actually a massive evolutionary hurdle. And the text uses a brilliant analogy to explain how genes solved it, referencing that classic sci-fi story, A for Andromeda.
Oh, I love that one. So in that story, an alien civilization in the Andromeda constellation wants to spread its culture to Earth. But they are 200 light years away. They can't possibly control anything on Earth in real time.
No, the lag is too huge.
Right. If they send a command, it takes 200 years to arrive, and a reply takes another 200 years. So they are forced to completely abandon any idea of micromanaging the situation.
Instead, they broadcast a single, massive set of coded instructions to build a giant computer. And that computer is programmed with general rules, strategies, simulations. Once it is built on Earth, it is entirely on its own. The Andromedans aren't pulling the strings anymore.
They just set up the initial programming and let the machine handle the day-to-day operations. And our genes face that exact same time lag problem, don't they?
They really do. They cannot react to a predator flashing out of the grass in real time. They are locked inside our cells, way too slow to pull a lever and make us jump. So instead, they build us an executive computer, our brains.
And they pre-program it with general rules of thumb, like sugar provides energy, so make it taste good. Pain indicates tissue damage, so avoid it.
Run away from large, fast-moving objects with sharp teeth.
Exactly. After setting those parameters, they just hand over the keys. The brain takes over the fast-paced chess game of life.
What's fascinating here is how this need for real-time prediction ultimately led to the evolution of consciousness. The genes blindly realized, so to speak, that the world is just too unpredictable to program every single response in advance. You can't anticipate every single predator or every single source of food.
So they gave the brain a master rule. Simulate the future, learn from the past, and just do whatever you think is best to keep us alive.
Exactly. Consciousness is just the ultimate evolutionary workaround for the time lag of DNA. We feel like we are making independent choices, but we are just running complex simulations within the parameters set by those ancient, ruthless molecules.
Those Chicago gangster molecules, as the text calls them.
Calling them Chicago gangsters is so apt. They're completely self-serving, totally cutthroat. They only care about their own replication in the gene pool.
But wait, if that is the case, if we are run by brains programmed by utterly ruthless, selfish genes, why is the natural world so full of apparent altruism?
That is the big paradox.
Yeah, I mean, the text talks about kamikaze worker bees that literally rip their own internal organs out to sting a honey robber, dying to protect the hive. Or ground-nesting birds that see a fox approaching and deliberately limp away, faking a broken
The
wing.
distraction display, yeah.
Right, to lure the fox away from their chicks, putting themselves in massive, sometimes fatal danger. How does a ruthless gene mechanically program a survival machine to commit suicide for someone else?
That paradox is the core problem the selfish gene theory has to solve. To understand it, we have to look at how a gene might recognize copies of itself in other bodies. Because if a gene can make a body sacrifice itself to save multiple other bodies that contain that exact same gene,
Then the gene itself thrives in the overall gene pool, even though the original altruistic body dies.
exactly. The text introduces this bizarre thought experiment to explain that recognition, called the green-beard altruism effect.
Oh, right, the green beard. So the idea is that a single gene randomly mutates to give you two things: a physical label, like a bright green beard, and a behavioral rule to be exceptionally nice to anyone else who happens to have a green beard.
Right, but relying on a single gene to perfectly execute a complex physical label and a complex behavioral rule seems incredibly risky.
Yeah, it sounds statistically far-fetched for a blind evolutionary process. Is there a less arbitrary way for a selfish gene to recognize copies of itself?
There is, and it's why nature rarely uses arbitrary physical labels. The far more reliable, statistically sound way to recognize shared genes is through kinship. And this brings us to W.D. Hamilton's theory of kin selection. You don't need a green beard. You just need to know who your relatives are.
Which makes sense. I mean, we all know the basic math of genetics, right? You share exactly half your genes with your children, but also half your genes with your siblings. You share a quarter with your grandchildren and 1/8 with your first cousins.
And what is wild is how animals unconsciously act as actuaries using those exact fractions. They perform an unconscious calculus based on those fractions.
The text uses a great example involving mushrooms to illustrate this mechanism. So imagine you are an animal and you stumble upon a patch of 8 delicious mushrooms. You could eat all of them yourself, but you are full after 3, and eating the rest only gives you a marginal benefit.
All right, so say each mushroom is worth a certain amount of survival points. Let's call it plus 6 points. If you eat 2, that's plus 12 points for your genes. But what if you give a food call and invite your brother and your cousin to share the rest?
The selfish gene basically calculates the return on investment. Your brother shares half your genes. When he eats 2 mushrooms, he gets 12 points, which translates to 6 points for your genetic legacy.
Because of that 50% overlap.
Exactly. And your cousin shares 1/8 of your genes, so his 12 points are worth 1.5 points to your genes. When you tally it all up, the net benefit to your own genes is mathematically higher if you share the excess food with your kin rather than just hoarding it for a tiny personal gain.
And just to be clear, the animal isn't sitting there with a tiny calculator doing fractions.
Obviously not, yeah.
The genes just program them with emotional rules of thumb, like feel a strong bond with the individuals you grew up with in the nest, or feel an urge to share food when you are full. They act as if they did the complex math, even though they were just following chemical urges.
But those blind rules of thumb work out statistically in the gene's favor over millions of years. But here's the catch. Whenever a simple rule exists in nature, another selfish machine will eventually evolve to exploit it.
Oh, absolutely. Communication in the animal kingdom turns into this massive battleground of deceit.
I want to look at how that actually works mechanically. Like, take the anglerfish. It sits on the ocean floor, perfectly camouflaged, and it just dangles a little piece of flesh from its head that wriggles exactly like a worm. Small fish have a genetic rule of thumb. If you see a small wriggling worm, eat it.
And the anglerfish mechanically exploits that hardwired simulation. The small fish swims in, and the anglerfish swallows it whole.
Another masterful exploiter of these rules is the cuckoo bird. I mean, cuckoos do not build their own nests. They lay their eggs in the nests of other bird species, exploiting a very simple rule programmed into the host parents. Feed whatever small, gaping mouth is sitting in the nest you built.
And it gets worse. Some cuckoo chicks even hatch early and physically push the host bird's real eggs out of the nest to ensure they get all the food.
Wow. And the mechanics of that arms race are just incredible. The host birds start evolving sharper visual discrimination to recognize when an egg doesn't look quite right. They learn to spot the imposter and throw it out.
Right. And in response, the cuckoo genes that survive are the ones that happen to produce eggs that perfectly mimic the color and speckling of the host's eggs. It becomes a back-and-forth escalation. Better mimicry forces sharper host eyes, which forces even better mimicry.
Here's where it gets really interesting, though, challenging that clean math of kin selection we talked about earlier. We noted that you share 50% of your genes with your sibling and 50% with your child. Mathematically, they are equal.
They are, yeah.
But in the messy reality of the natural world, certainty is just as important as the mathematical fraction. Because even if the math says my brother and my child are both 50% related to me, I am only 100% certain of my own genes. I am the only individual I can fully trust not to be a genetic imposter.
If we connect this to the bigger picture, that concept of certainty completely shapes family dynamics. Think about it. A mother who physically bears a child or lays an egg is 100% certain that child carries her genes. There is zero doubt.
But a father does not have that luxury.
No, he doesn't. The physical disconnect introduces the threat of cuckoldry. The constant danger of being tricked into spending massive energy raising another male's offspring means fathers have significantly less genetic certainty.
Which perfectly explains why maternal care is so much fiercer and so much more common across the natural world than paternal care or sibling altruism. The mother's genetic investment is guaranteed. The father's investment is always a statistical gamble.
Exactly. And even that fierce maternal instinct is just a blind rule that can misfire when applied in the wrong context. The text mentions bereaved monkeys who lose a baby, and they are so driven by this mechanical urge to mother that they will sometimes kidnap a baby from another female in the troop.
Oh, wow.
Yeah, and from an evolutionary standpoint, that is disastrous. She is spending her precious energy raising a rival's genes.
Or what about dolphins rescuing a drowning human? That's always in the news. They are just acting on a blind rule. If you see a long thing thrashing near the surface, push it up to breathe. We look at that and see this beautiful act of interspecies compassion. But to the genes, it's just a mechanical misfire, a rule being triggered by the wrong stimulus.
Right. It forces us to ask a larger question, though. If the natural world is driven by selfish deception, constant exploitation, and ruthless competition, Why isn't it just a nonstop bloody free-for-all? Why do animals so often settle disputes peacefully? Why do they posture and bluff instead of just fighting to the death over every piece of food or territory?
That's a great point, because if I'm a ruthless Chicago gangster, Gene, and I meet a rival, my first instinct should be to just eliminate them. But as the text points out, fighting has massive hidden costs. If you kill a rival, you might inadvertently be helping a third rival who is also competing with the guy you just killed.
You essentially do their dirty work for them.
Right, and you took on all the risk of injury to do it.
This is where game theory comes in. A biologist named John Maynard Smith ran the numbers on these hidden costs and found what he called an evolutionarily stable strategy, or ESS.
The text's breakdown of the hawk and dove model illustrates this perfectly. Let's say you have a population with two distinct fighting strategies. Hawks always fight brutally to the bitter end, only stopping if they are seriously injured. Doves, on the other hand, just posture and threaten. They puff out their chests, they scream, but the moment things get physical, they turn and run away.
They never take actual physical damage.
Exactly. So if a population is entirely composed of doves, life is peaceful but completely unstable. The moment a single mutant hawk is born into that population, he dominates. He wins every single dispute without a scratch because the doves always run away. The hawk genes spread through the population incredibly fast.
But the environment changes as those genes spread. Once the population is mostly hawks, every time a hawk gets into a fight, he meets another hawk. The fights result in terrible, crippling injuries or death. The cost of fighting becomes so incredibly high that suddenly being a dove is an advantage again.
Even though doves lose every single fight.
Right, because they never get injured, meaning they live longer than the battered hawks and have more chances to breed. The math behind this dictates that the population will naturally balance out at a specific, stable ratio of hawks to doves. It reaches an equilibrium.
And once it hits that exact mathematical tipping point, no mutant strategy can invade the population and do better. The system regulates itself not out of some desire for peace, but out of sheer mathematical inevitability.
That same mathematical pressure explains why animals evolved poker faces. The text looks at the war of attrition model, where animals just stare each other down, waiting for the other to give up.
So it's a classic staring contest.
Exactly. And in a staring contest, any tiny movement that signals you are about to retreat, like a whisker twitch or a shift in weight, is completely fatal to your chances. If I see your whisker twitch, I know I just need to hold out for one more second to win.
So evolution heavily penalizes any animal that gives away its intentions. Animals evolved completely blank, unpredictable poker faces because successful deception in that specific scenario is just impossible. It forces a bizarre kind of honesty.
It really does.
I have to admit, though, when we talk about populations settling into stable ratios and achieving these mathematical balances, it sounds dangerously close to teamwork. It sounds like animals are unconsciously teaming up to create a balanced society for mutual benefit.
It does sound like that, yeah, but we have to avoid falling into that trap. The text uses the analogy of a rowing crew, the oarsmen, to demonstrate why it is absolutely not teamwork.
Oh, this is a great analogy. Imagine a rowing coach who has a pool of rowers. Some are left-handed, some are right-handed. A perfectly balanced boat needs 4 of each to go straight and fast. But this coach is completely blind to handedness. He doesn't know who is left or right-handed.
He just randomly throws 8 guys in a boat, races them against other random boats, and keeps the guys from the winning boats, discarding the losers.
Over time, by pure chance, the boats that happen to have a good mix of left and right-handers will go faster and win the races. The coach keeps selecting those specific men. Eventually, through blind selection, he will arrive at a pool of rowers that naturally forms a perfectly balanced boat of 4 lefties and 4 righties.
It looks like conscious teamwork. It looks like the rowers organized themselves. But the left-handers only succeeded because they happened to be in an environment full of right-handers and vice versa.
And genes operate the exact same way. Good genes are just genes that happen to survive well in the environment created by all the other genes in the gene pool. A gene for sharp carnivorous teeth is an incredibly successful gene in a lion, but a fatal gene in an antelope. It is not teamwork, it is selfish survival in a shared environment.
That dynamic is why an evolutionarily stable strategy is so powerful. It works because it is completely immune to treachery from within. Think of human price fixing at gas stations.
Oh, like when all the station owners on a block agree to keep prices at $5 a gallon, they all make a great profit. That is a conscious group conspiracy.
But the conspiracy is fragile.
Yeah.
The second one owner gets greedy and drops his price to $4. He steals all the customers. The whole agreement falls apart instantly.
Conspiracies are deeply vulnerable to cheaters.
But an evolutionarily stable strategy is immune to cheaters. It is the only strategy that survives the ruthless logic of the selfish gene.
So, what does this all mean? If an evolutionarily stable strategy proves that animals aren't consciously teaming up, but rather settling into a mathematical stalemate, that totally destroys the old school idea that animals do things for the good of the species, doesn't it?
It completely shatters that comforting myth, yeah. And you see that myth most clearly in the historical debates over animal population control. V.C. Wynne Edwards proposed a massive group selection theory based on that myth.
Right. He looked at nature and saw that animal populations rarely explode and eat their entire food supply. They seem to regulate their birth rates. So he argued that animals altruistically limit how many babies they have to save the species from starvation.
Which sounds nice.
He even proposed that holding territories was basically a system of breeding licenses. Like, if you didn't get a territory, you politely agreed not to breed for the good of the group. He even suggested that when huge flocks of birds swarm in the sky at dusk, they are taking a population census, counting each other so they know whether to have fewer chicks next spring.
Under the lens of the selfish gene, that poetic idea completely collapses. Let's look at the mechanics using the text's analogy of guillemots. They're these cliff-dwelling seabirds. Imagine a group of guillemots actually did what Wynne Edwards suggested. They all politely agree to lay just one egg each to keep the population perfectly stable.
They even agree to babysit unattended eggs for the good of the flock.
Right. What happens the moment a single mutant cheater gene appears in that population? This female bird lays 2 eggs, and instead of sitting on them, she flies off to gather food, knowing the polite, altruistic birds will follow the rule and incubate her extra eggs for her.
The cheater gets double the offspring for half the work. In just a few generations, her selfish genes will completely overrun the population. The polite babysitters will just be wiped out. Altruistic birth control is biologically impossible because it is endlessly vulnerable to selfish cheaters.
Which means the biologist David Lack was right. Animal birth control isn't altruistic at all. It is purely selfish.
Birds lay a specific clutch size, say 3 eggs, not to save the species, but to maximize their own surviving offspring. The mechanics are really simple. If a bird gets greedy and lays 6 eggs, she won't be able to find enough worms to feed them all. All 6 chicks will starve and her genetic legacy dies.
But if she lays 1 egg, she's not maximizing her potential. 3 eggs is her selfish optimum. Restraint in nature isn't nobility, it's just calculated selfishness.
It always comes back to the gene. Every action, every hesitation, every act of apparent sacrifice is mathematically tuned to propagate those immortal coils of DNA. So when you look in the mirror today, remember what you are looking at. You are a brilliantly engineered temporary engine.
A survival machine.
Exactly. Your familial love, your restraint, your very consciousness, all of it is an evolutionarily stable strategy forged by ruthless molecules competing in a primeval soup billions of years ago.
But you know, there is a final thought drawn from the text that flips this entirely on its head.
Oh, right. The culture aspect.
Yeah. We've spent this entire deep dive establishing that we are born selfish and that universal love makes no evolutionary sense. But humans are unique. We're dominated by culture. The author hints that culture, ideas, beliefs, art, technology acts like a new kind of replicator. A replicator jumping from brain to brain instead of body to body.
A cultural virus spreading through the executive computers.
Exactly. And this raises just a profound question. If our genes built our brains, could the ideas housed in those brains eventually become powerful enough to rebel against the very genes that created them? Could our cultural software override our genetic hardware?
It is a rebellion that no other species in the history of the planet has ever even aspired to. Can the survival machine finally take the wheel? That is something to chew on. Thank you for joining us on this deep dive into the source material. Keep looking closely at the world around you and never stop questioning the hidden motives behind everything you see. We'll catch you next time.